Oh, hey, hi there. How you doing? I didn't see you come in. Come on in. Come on, have a seat. I'm glad that you came in. I was just remembering that story you told me. This was a recent story. It was just last week, wasn't it? You were working for that company. I know you worked for that company as a budget manager, and the company is in that Philadelphia metropolitan area here, and they make breakfast cereal. And they're like a knockoff brand, an off brand, I should call it, not a knockoff. But they compete with General Mills and etc. And you were telling me how starting the budget cycle, and the president gives you a call and says, listen, I know you're doing the budgets, and the marketing department has this, exciting plan they have for a promotion. But I want you to validate the numbers. They're good at promotions, but sometimes they're not so great at validating the numbers. I want you to validate the numbers. So you said, okay, sure, I'll do it. Yeah, what do you want me to do? So you went, you phoned them up, had a meeting. Tell me about this promotional campaign. So they told you. What they want to do is, since the Philadelphia Eagles are having such a great season, people are so excited about their season, they want to capitalize on this. So they've contracted with the Eagles to have bobbleheads of 6 of their players, and they want to put the bobbleheads inside their cereal, and then they'll do a marketing campaign. Come, buy our cereal and collect all 5. It sounds like a pretty nifty idea, doesn't it? All right, so here, let me show you. Right here, they're going to have bobbleheads for the quarterback, Jalen Hurts, for the wide receiver, A.J. Brown, for the center, Jason Kelsey, for the kicker, Jake Elliott, for the running back, Miles Sanders, and the linebacker, T.D. Edwards. So, all right, that sounds pretty good. So what'd you do next? Well, you were telling me, you went to the meeting, they're explaining, the details they have based on the geographical area, how many people are in this, this area. Here, I'll put up on the board what you were showing me right here. So here it says that, right here, the Philadelphia metropolitan area, which includes the surrounding counties and Camden, New Jersey, and Wilmington, Delaware, has a population of 6,245,051. That's according to the U.S. Census. And they estimate the marketing, as they do these promotions, they think that 2% of the people will go out and buy the cereal to collect all 6 players. So 2% of that above number would comes to 124,901. And, we'll round that to 125,000 people. So 125,000 people buying 6 boxes of cereal would be 750,000 additional boxes of cereal during this campaign. We sell it to the wholesaler at the supermarket. We sell it to the retailer, I should say, at the supermarket for $2 a box. So therefore, it's an increase of revenues of $1.5 million. Now, the marketing department says quite right that that's a low number because the people will likely have to buy more than 6 boxes. It's random. They don't know how many boxes. They don't know where they are. They have to buy a box of cereal to see what they get. They have to buy more than 6 boxes to collect all 6 players. But they just don't know how many. So you took and you made the presentation of what they had told you, right, to the president. And the president says, okay, that's interesting. Well, what do you think about that? What do you think about that? And you said, well, obviously there's a problem with, the fact that they only have 6 boxes purchased. It's obviously going to be much greater than that. And actually, this is very analogous to the coupon collection problem. And so the president, she kind of scratched her head and says, what's the coupon collection problem? I'm not really familiar with that. So right here, it's up on the board here. And the coupon collection problem is that in probability theory, the coupon collector's problem asks if each box of a brand of cereal contains a coupon, and there are n different types of coupons, what is the probability that more than T boxes needs to be bought to collect all n coupons? And so the president says, so this is a probability question, huh? And you said, yes, it's a probability question and it can be solved. There's a mathematical answer to it. So she says, well, okay, how do you do that? So right up here, show you on the board again, right? You can show you do it. So for example, when you buy your first box, of cereal, the probability of getting one of the 6 players is, well, it's 100%, right? So that's 1. You go for a second box, the probability of getting one of the remaining 5 players would be 5 out of 6, or 5/6, right? But we take the reciprocal of this. We take 6 over 5, that equals 1.2. Now for the third box, it's the same kind of scenario. The probability of getting one of the 4 remaining players will be 4 out of 6. 4 divided by 6. We take the reciprocal again. It becomes 6 divided by 4, which is equal to 1.2, 1.5. And basically, we continue in this manner and then we add them all up. We aggregate them, and it comes to 14.7. So once again, just to show you, the first one was 1. The second one is 6 divided by 5 is equal to 1.2. The next one is 6 divided by 4 equals 1.5, all the way down to 6 divided by 1 equals 6. You add them all down, it sums to 14.7. We round that to 15. Basically, we're saying that a person who's interested in this, they want to get, all of the players, all of the bobbleheads, the expected value is that we'll purchase 15 boxes of cereal. Huh, well, that's a lot more than the marketing department said. Matter of fact, it's 2.5 times what the marketing department said. Do we have the capacity for that? So right here, if we have 125,000 people times 15 boxes, that's 1,875,000 additional boxes of cereal. Clearly, you need to make sure your supplier is prepared to make and deliver an additional 1,875,000 boxes of cereal in this time frame during this campaign. I mean, you don't want people, just buying 1 or 2 and then getting upset because they can't get the rest, right? You need to have your supply situation ironed out, and that's why you need a good estimate, right? Okay, so the president's feeling pretty good about this. All right, I'm feeling pretty good about this. So meanwhile, there's another person in the meeting. The chairman of the board has got a nephew who's in business school. And this student, the nephew, is home for break and has asked the president, listen, it would be okay if he sits in on a few of your meetings to learn something about business. So your president says, okay, fine. Not a common thing, but okay, fine. So, this young guy, he's kind of pipes up and says, oh, I got a great idea. What if we, I can't make my voice. What if we roll out not just for 6 players, but we got 11 people in the offense, we got 11 people in the defense, we got a kicker, we got a punter. How about we do 24 bobbleheads, put those in the boxes? How many boxes of cereal can we sell then? The president says, all right, slow down. First of all, we didn't contract with 24 players, I think it's gonna be kind of crazy, but okay, let's run the numbers. What do you think it would be? So they turn to you. You're the expert, you got the numbers, right? You're figuring it out. So, you said, okay, well, actually, there is a formula for that. I mean, you can go through the same scenario we did with the 6, the 6 fifths and the 6 fourths, but there is a formula. And, it's right up here on the board. Let me show you what it is. So, what it is it's n times ln. That's the natural log of n plus the Euler-Mastrioni constant. I said, what the heck is that Euler-Mastrioni constant? It's something the statisticians came up with. There's all kinds of things you can read on it, but it's a constant. You put it in there, okay? And then you add 0.5. Doing it in Excel is really easy. You'll just put in equals. Then your count of n, in this case, it was 24, if that's what you want to do. 24 times open parentheses ln, which means natural log, open parentheses 24, close it, plus 0.5771. That's the Euler-Mastrioni constant. It's always going to be there. That's the same constant no matter what your n is, okay? And then you close the parentheses and add 0.5. You hit enter, boom. Excel comes back with 90.62369. 62369. Basically, you're going to be selling 91 boxes of cereal for each person. Well, that's not really going to make a lot of sense. 90 boxes of cereal is about a 2-year supply. That doesn't seem advisable, obviously. So I said, that's really interesting what you did there. I've never even heard of this coupon collectors problem. But this was a really ingenious way to estimate, for your supply chain, how many boxes, that you're going to have to make sure are in the production line to sell the cereal for this, promotional campaign. You're really using mathematics and statistics in a useful and helpful, value-added way so that the president and the management team can make good decisions. I said, that's just fantastic. A very useful business tool. So, I asked you, how'd it work out for you? Well, the president was very pleased. Basically, she says, listen, I want you to continue using your mathematical and statistical tools in all areas, of the company, even though, you're the budget manager, there's a lot of places where it could be useful. And, I think there's a promotion and a raise in this for you too. I said, well, that's just fantastic, Good for you. Good for you to take a lot of this mathematical stuff and apply it on a real basis that people can use in their lives or in their businesses. And that's why you are one ace accountants. So let's give you a round of applause, all right? There you go. Good for you. Good to see you.